the black box testing is about the idea of black box testing is we try to test following the specification to check how the program works and to test that we don't care what is inside the program or our software. We just care that the software must behave like what? Like we expected. So we try to find the proper input to get the expected output and try to find out that if we generate the group of input as a equivalent classes to simulate how the system should respond without any detail inside the code or the program. We just test, we try to find input and try to make input that cover every possible output of the system and test. And we use the idea of equivalent class and boundary value to find what should be the proper data for testing, which is cover as much as possible for our possible behavior or output of the program. But that is the black box. We don't care what is inside. In the other way, in software testing, the next theory is white box testing. What is a white box? As I said, it's actually it uses the word white, but from my explanation, it's a clear box. We should be able to see what is inside how the code is running. So what is a white box? It's opposite to the black box. We should in the white box testing, we need to see, we need to be able to access every possible method inside the box. Just like the white box testing is just we try to find input, and inside the box we must be able to identify the possible part or the possible execution in the program. That is why we call it a white box, because we might be able to see how the code works in detail, see how every execution or we can just like we can see every line of code. That is the idea. Okay. And to start design the test following the white box testing, since we are not going to binding our class with any programming language. So what should we use to depict or to represent the code or the program? We are going to use, normally people use a control flow graph. Have you ever studied this kind of control flow graph before? If not, it's okay, just like the control flow graph will be for this example, every line of code, every execution, just like this one. So normally in most of the programming language, we have a line of code when we do programming, right? And then every execution, every line that the code is executed, we will count it as some things. In this slide, we have each line for each node. And then, but in some of the condition, if in node number 3, if you divide into 2 nodes, represent the true and false here. And after execution of if is n, if you combine to be one line of code, and then is this going to the next execution? So we try to depict the code as a unit. And in the idea of using the control flow graph to represent the code, it's like we use the graph data structure, which is the graph consists of a finite set of nodes or vertices and the edge, which connect a pair of nodes. Just like we have the vertex or the node and the line that connect each node. Okay, I think this is like, for simple translation, we translate each line of each code execution into one node, and we have the edge that connect for each node. Just to see that, okay, from this line to this line, it's like one execution, one edge. But from this line, we have for loop here. For this for loop, we are going to do something. If they have something else, we should input the other vertex or node here. But from here we have dynamic to represent the for loop. So at the end for, what happened here is, well, the edge should be point out to this node, and this will repeat until 0 to 10, and then it will execute to from this N4, it will execute to the other node or vertex. Just like this is the idea of using the graph data structure to represent node and edge. Sorry, to represent node and edge as a program execution. Why? We define each vertex or node as the statement, like this example. The edge is the control flow which lead from one statement to other statement. Okay, this is how we depict the program. This is the same. For is for the second here. If is for the third, for this corresponding code. But here, okay, I should move it a little to make it. Sorry. Like this. It's like, what happened? Just like each execution line will be represented by the node, and after the line execute, we have an edge to represent where it's go next. That's it. Okay, and okay, this will be talking about later. But how about this is for the level of code? But in one kind of testing, the integration test, we are going to which is we are talking about sequence diagram, and the sequence diagram or collaboration diagram we can show as a control flow graph for one method. We have each node represent the method and call by this edge instead of statement. But it's the same way of depicting how the program flow, how the execution process going on. So what should be the control flow of this? Can you draw it? Can you draw this control flow graph for this example? If I What should be control flow graph for this code? We have 1 and then divide into 2, and we have this one, and we have the while loop inside here. Okay, but this is I ask you to work this on this by yourself, and I will give you the answer later. But the idea is that you must, if you see some kind of code like this, before you can start doing the white box testing, you need to create the working process is that you need to create a control flow graph. I'll leave it here. Why we need to create a control flow graph? Because the quality of the test is depend on the completeness of the test, and to verify that the test is complete, we must test all possible graph. We try to cover all the possible graph, or for the code, we try to create a test that run into every single execution of the code in your program. That is the idea. And if we can run through that with the proper selected input, it means that we are test through all of the possible output in the code detail of the program. So since the quality of the test depends on how many percentage, how many completed of the code that we can run. So there are some kind of coverage or possible path. If we have statement coverage, every statement should be executed from this example for statement coverage. It means that for this example, we have 1, 2, 5, 6, 7, 9, 10. 1, 2, 4, 5, 6, 7, 9, and 10 here. And then 1, 2, 3, 5, 6, 8, 9, 10. So this is statement coverage. Every segment is executed. This is one idea of testing. Every node here is executed, but we don't care. Just the smallest one, just like every node should be executed. This is we call it statement coverage. So how do you find statement coverage of this code? First, yes, we need this kind of diagram. Okay, you draw this diagram and you find the possible statement coverage. What else? Next is condition coverage. Every branch of condition should be executed. This example for statement and condition should maybe just a little confusing, but in condition coverage, we just care that every condition 1, 2, 3, 5, 6, 7, 9, 10 is executed, and 1, 2, 4, 5, 6, 8, 9, 10 is executed. So it means that it does first for the statement, we just execute every statement without what? Without carrying, we can have at this side, or we can have at this side, or we can have this one, or we can have this one. It's okay. But in condition, just like every condition must be executed. And so you need to create the diagram and find out what is different between this statement coverage and condition coverage, because this code is designed to give a difference between statement and condition coverage. And then what's next? Path coverage. the path coverage is that every possible run. You see that statement condition have only two type of coverage, two flow. But for the path coverage, we have 4 execution path. It means that for path coverage, it means all possible should be covered. All possible execution must be executed. Okay. Any question now? Not yet. Yes. Okay. So we start from whiteboard. The whiteboard is testing the code. So testing the code, we may not use the code itself. We in the phase of design the test. So we use control flow graph to analyze all possible things from the code, and we just care about execution and execution. So it's like if one line is execute and what should be the next execution and what should be the next. So we represent the system by the control flow graph as a graph data structure. We use node and edge, or sometimes they call it vertex. And from simple scenario, we have a program, a code. From this program, we should time to the order. Diagram to depict what is the control flow for this code, and then we analyze the flow, checking the coverage of the code, how many possible flow can be executed in the from the diagram, and the way of checking, maybe we can use statement coverage, path coverage, and condition coverage. It depends. But don't worry, what should be the proper way of test? We should use path coverage. But this is the idea. We need to test every possible part, not just every possible condition or possible statement, but in the real world, in the coding, we have 200 or 300 or 400 lines of code. We have a lot of decision loop. We have a lot of for and why and blah blah blah. Sometimes, this is the idea. If we can do that, okay, if we can do check all the possible path coverage. So you will be asking to do what is the path coverage for this for this code, but what happened in the real programming environment, in the real programming, in the real code, we have a problem of statement explosion. What is it? In your loop, in the app, just like for this loop, it contains many many subsequent method call and many idea of loop and decision. Just a moment. Sorry. In the real program, when we do the actual programming in your loop, the answer is how many possible parts existing in your code. And if there are a lot, the loop can cause the infinite part, as a different loop provide different part. So the idea to fix the number of to find out the proper number of the loop. The selected number of the loop should be used. So in the complex control flow chart, how do we know that how many parts we need in each coverage criteria? The theoretical thing is we use Mackay psychometric complexity. What is it? This is a formula. This is a theoretical formula that we measure the number of linear independent parts through the program, and we use this formula Vg equal to E minus N plus 2 or H, number of H minus the number of node plus 2, or Vg equal to number of closed loop plus 1, or the number of the node that contain the condition plus 1. This is a lower bound of number of possible parts. We just by this, it's okay, but if you can find, if the loop is too complicated, we can use this formula to find out what should be the possible number of parts we need in each coverage criteria. So the part number should be E minus N plus 2, or a number of closed loop plus 1. This is suggestion, this is the formula. So if you have something like this, for psychometric complexity, what should be the number of the output possible part? How many? Start from A, B, C, G, or A, B, C, B, C, G, or A, B, E, F, G, or A, B, E, A, D, E, F, G, or A, D, F, G. So this is possible part coverage for this. We have 5, and condition coverage will be 4. So what should be the number of possible parts? If you have something like this, we can use this formula, just like number of H minus number of nodes plus 2. So how many number of H? We have 4, 5, 6, 7, 8, 9. We have 9, and then how many nodes? We have 7. So we have possible part coverage for 9 minus 7 plus 2, it will be 4. Or what should be the number of the closed loop plus 1? This is 1 closed loop. This is 1 closed loop, and this is 1 closed loop. We have 3. So 3 plus 1 will be equal to 4. Okay? And we can use 4 possible coverage for this complexity control flow graph. The next question, how about this code? So before you can do this, you need to create your control flow graph corresponding to this code and find out what should be how to use this formula for Vg, E minus N plus 2, and number of the loop plus 1. And you can check whether it's equal or not. If it's not equal, something happened in your flow diagram. Okay. So to do the test is to find the test data that dive the part. What should be the data that dive to all of this part? Can you find that? What should be the data that dive to all of this part? Okay, it doesn't matter. This is I will give you the example at the homework, so you can find out from somewhere else and give me the answer of what should be this. So the idea is that we find all the parts and find the data that dive up through that all the possible part inside the program. And your homework will be this one. Create control flow graph. The second homework, create control flow graph and find the psychometric complexity value and data to cover all the possible parts. For this example, actually, this is what is it? It's the code for triangle problem that we talked about yesterday. Okay. Any question now? Okay, if not, I will give you the homework and give you the guideline link for you to complete your homework, and then I will wake up on Monday afternoon. Okay? Any question? Okay, if no question, I will give you assignment maybe today or tomorrow, and then okay. If you have a time, just join the class on Monday. If not, you can watch the video later. And thanks for joining. Okay, I will stop recording. The idea may be small and may be fast, but you need a time to practice. You need a time to practice before you can understand how to draw the control flow graph, how to identify each line of code. Okay, and take a time, do your homework, and then see you on Monday.